Hello, this is Mrs. Sargent, and this is lesson 2.2b, Bohr models and atomic models. So Niels Bohr, he was a Danish scientist. He worked with Rutherford, and he proposed that electrons have enough energy to keep them in constant motion around the nucleus, and he compared this motion of the electrons to the motion of the planets orbiting around the sun. And planets, they are attracted to the sun by a gravitational force, but they moved with enough energy to remain in stable orbits around the sun. And so he proposed that there is similar pull on the electrons. The positive charge of the nucleus pulled that negative charge of the electrons to keep them inside the atom, but also there's enough energy to keep them moving around the nucleus. Bohr's view in the model he proposed in 1913, and he called this the planetary model. So what is the maximum number of electrons in the first energy level? The first energy level has 2 electrons, maximum. And if you look at your periodic table in the first row, you have hydrogen and helium. So those are the 2 atoms that if they had a full outer energy level, they would only have 2. The maximum number of electrons that can be in the second energy level is 8 electrons. And I didn't have a place for you to write this down, but in the third energy level, there is a maximum of 18 electrons. And any energy level above the third energy level can have up to 18 electrons. So the electrons in the outermost energy level are called valence electrons. And valence electrons are the electrons that are involved with bonding. So, therefore, many of the chemical and physical properties of an element are related to the number and arrangement of the valence electrons. Everything underneath hydrogen has 1 valence electron. Everything underneath beryllium has 2. Everything underneath boron has 3. So those elements are going to have similar chemical and physical properties because they have the same number of valence electrons. 8 valence electrons is called a full octet. And all atoms want to have a full octet, except for hydrogen and helium, and they just want those 2. They want a duet. So the full octet is 8 valence electrons, and all of the noble gases besides helium have that full octet, and so because they have that full octet, they're not going to bond with anything. So we're going to draw a Bohr model for lithium and chlorine. If you take a look at lithium, the atomic number is 3, so we have 3 protons. And the neutrons is the mass number minus the atomic number. So to find the most common isotope, you're going to take the average atomic mass and round it to a whole number, which is 7 for lithium, minus our protons, 3. That gives us 4 neutrons. That is in our nucleus. In our first energy level, we said that we can have a maximum of 2 electrons. Well, we need a total of 3. So we're going to put 2 electrons in that first energy level. Notice that I made another ring outside the nucleus. The electrons are not in the nucleus, So the first energy level is actually the second ring. And then the second energy level is where that third electron is going to be located. And we're only going to have one electron in that third energy level. For chlorine, the atomic number is 17. And to find the number of neutrons, we take the mass number minus the number of protons. So the average atomic mass is 35.45. Rounding that to a whole number would be 35. Anything plus 0.5 or below, you're going to round down. Anything 0.5 and above, round up. So 35 minus our number of protons, 17, gives us 18 neutrons. And then that's our nucleus. So then we need a total of 18 electrons. We're going to put 2 electrons in our first energy level. Our second energy level can have up to 8, and we're going to need those 8. So we're going to put in our 8 electrons into our second energy level. And the electrons like to be paired, so that's why I'm pairing them up here. They kind of make this cross up, down, and across on the different energy levels. And then, so 2 plus 8 is 10. Well, we still need 7 more electrons. So we're going to put 7 in our third energy level. Then our Bohr model for chlorine is complete. So that's how you draw Bohr models. Please stop by and ask me if you have any questions. We'll be drawing Bohr models just to help us with the structure of the atom. Even though that's not our current model, it still helps us look at the overall structure of the atom. So thanks for stopping by. Have a great day.